So, I mean, I'm sure everybody in this room understands and realizes the fact that performance is important, being fast matters, right? As users of the internet, as developers of the internet, we tend to understand that, we don't like slow experiences. Slow experiences aren't particularly good for business or for customers, for users, anyone. So in this talk, I'm hoping to outline some of the kind of the moral and ethical aspects behind performance, perhaps. So we will look slightly at some financial aspects, looking at the sort of very westernized, very capitalistic worldview of performance. But then we're going to dive into some of the more moral and international problems we deal with when we look at web performance. It's quite a big talk, actually. There are nearly 100 slides, so I should probably get started. My name's Harry. I'm a consultant performance engineer from the north of England. I tend to work with clients all around the world, helping them make more scalable, more long-lasting, and more robust front ends. I work with quite a lot of different clients. I've been very, very fortunate in my career to work with some very, very exciting and interesting names. But there's one client in particular, this company right here, Trainline. They released a statistic a couple of years ago that said if they could reduce latency by just 0.3 seconds, customers would spend an extra £8.1 million a year. Just by improving performance by less than a third of a second, they saw an £8 million increase in spend. Now, I've been helping the Trainline with this body of work, and it's genuinely been very, very fascinating. And the good news is it's actually really easy to make a website just 0.3 seconds faster, so we've definitely achieved our goals. But the numbers here are absolutely staggering. £8 million a year just for the sake of 0.3 seconds. And it's a wonder that more companies don't focus on this, but I still, in my work as a consultant, find it very difficult, surprisingly difficult, to convince stakeholders, project managers, product owners, the business, that they should fund performance efforts. Does anybody else feel that's the case? Everybody understands that performance is important, but very few people are willing to pay for it, right? Same with accessibility, right? People will pay for carousels. They love carousels. They won't pay for a fast website, despite the fact that tests have shown it will make them so much more money. Another interesting case study. Unfortunately, Netflix isn't a client of mine, but they saw a 43% decrease in their bandwidth bill simply by turning on gzip. Now, my first question is, who turned gzip off? Why wasn't gzip on in the first place? This case study really ought to say Netflix were wasting 43% of their bandwidth bill because they hadn't turned gzip on, right? But a simple config change, just a simple server change, managed to reduce Netflix's bandwidth bill by 43%. If you go to a restaurant this evening and the waiter decides to give you a 43% discount on your meal, you'd be really, really happy. Imagine saving 43% at Netflix scale. And also consider that they can't even gzip most of what they transfer anyway. Just gzip in their text assets saved them nearly half of their hosting bills. GQ, a lifestyle magazine, they cut load times by a very, very impressive 80%. And they saw, in return, an 80% increase in organic traffic. Right? So I'm not talking paid adverts or social. We're talking organic traffic increased by 80%. And of that increased 80%, time on site went up by 32%. So that's kind of a third, right? Now, the reason I've included this case study is because the previous two looked at money. They looked at either making money or saving money. What this case study shows us is that if you aren't directly dealing with e-commerce, a lot of my clients don't deal directly with e-commerce, they normally tell me that, well, we can't make more money on our website because it doesn't sell things. But performance will increase engagement. And I hate to mention it, but GQ, they run ads on their site. They're increasing ad impressions by 32%. They are eventually going to make more money out of this. Each of these case studies was picked from a site called WPOstats.com. Write this one down. Web Performance Optimization Stats, WPOstats.com, is a really great resource for finding case studies to do with revenue in e-commerce in 2015, right? You can filter and search and cross-reference all these things, and you can pull out case studies that are going to be very particular to your client or your business. I mentioned it briefly, but the reason I picked these three specific case studies is because they all tell us an interesting thing. The first one told us that performance will make our business more money. Faster websites sell more things. Selling more things means more money in the bank. Focusing on performance will save us money. Netflix saved 43% of their bandwidth bill. I worked with a client a couple of years ago who they commissioned a site to be built, and it was built very, very badly. And their hosting bill was enormous. Their homepage weighed 16 megabytes, none of which was cached. And they got about 1 million visitors a month. 1 million visitors downloading 16 megabytes of data, every single page view. Their bandwidth bill was about to bankrupt them, right? They were genuinely spending tens of thousands a month just on hosting. We managed to save them so much money just by doing a proper job. And finally, it makes users happier. We know this one. This is the most obvious one. Users enjoy fast websites. Nobody enjoys the slow pace of life that a slow website brings, right? Slow websites increase stress, increase frustration. Nobody enjoys using a slow website. But yeah, most of these are financial, and I want to talk a little bit in this talk about the kind of moral obligation we've got to users potentially in different environments and certainly different parts of the world. I've got 3 little stories I want to share with you. Each of these stories happened directly to me, so I guess the caveat there is that these are anecdotes, not data points. But also the thing is, each of these 3 things happened to me this year. So I'm not talking about the internet 5 years ago, I'm talking about the internet right now. First one, a friend of mine. A friend and I were running an event together in Leeds, where I live. My friend, he runs a really nice coffee shop in Leeds, and we were supposed to run this event. And I sent him an email, and it was an important email, and he just did not reply to me. And I was getting stressed out, because I was like, we need to sort the event. So I went into his coffee shop, and I was like, dude, you didn't reply to my email, what's going on? He's like, oh, I was in Thailand on holiday. The cellular connection out there was strong enough to send me a push notification, but I just couldn't open the email. I just could not access the email. I hadn't sent a 20 meg attachment. It was just a simple text email, but the data connection was too weak to even open it. The stories get better, right? This is like a boring one to start with, don't worry. This one was interesting. I get quite a lot of email from people asking for advice, asking for development or career advice. This person sent me an email, and I spent a long time writing a response. I wrote quite a big response to this person, and he just never replied. He didn't reply to say thank you or anything, and I was a bit like, that's kind of rude. But 2 weeks later, he did reply. And he said, I'm really sorry for my delayed response. I'm on a really bad connection. And I said, look, I will forgive your slow response if you tell me everything you mean by slow connection. And what he told me was fascinating. I'm currently at my parents' place in Rajasthan, which is northern India. Since my parents don't have a computer, they only consume the internet through their smartphone. We rely on internet services by telco providers, which in our town are still 2G. Some of them claim to be 3G, but I've never seen it working. So right now I've got my laptop connected via a Wi-Fi hotspot. Opening Gmail in the basic HTML version takes between 30 and 60 seconds. For every other website, I tend to just use mobile Chrome anyway because it makes data savings for me. A couple of things here, right? First thing, I've opened the basic HTML version of Gmail maybe 5 times in my entire life, and it always feels like the worst thing ever. Right? Oh, I can't believe the internet's so slow. But it opens within 5 or 10 seconds. For this person, the basic version of Gmail still takes nearly a minute. The second thing I want you to think about, when you go home tonight, you're probably going to have a router in the corner of your room, the corner of your living room, beaming out Wi-Fi. If you're very lucky, that will be backed by a fiber network. What this person's family has plugged into the corner of their room isn't a router, it's a commodity Android device with a permanent 2G connection. I tether my phone when I'm at maybe airports or in hotels or at conferences. I might tether my phone and I might get 3G or 4G, and I can feel that that's a lot slower. Imagine permanently tethering a 2G connection for your entire time online. This is how they get online 100% of the time. This isn't a temporary thing. This is how they get online every single day. The third story, and this is my favorite, well, it's my favorite because I'm not called @Harry on Twitter, so I don't know who got this notification, but somebody sent me a direct message asking for some advice, and this person was from Nepal. Now, in my analytics, and we will look at analytics as a tool later on, in my analytics, I'd found out that Nepal was a problem region for me. My site was slow in Nepal. So I said to this guy, look, whilst I've got your attention, can you just tell me, is my website slow for you? Because my website is apparently slow in Nepal. His response was absolutely amazing because he said, no, I don't think it's slow. I mean, I click on your site and it loads within a minute. And that didn't feel slow. To him, that didn't feel slow. Right? A couple of things to think about here. If we were in, a nice European city, maybe like Wrocław, and a website took a minute to load, we would assume the website was down. If it's taking a minute, we'd be like, oh, the website's down, I'll go somewhere else. Whereas this guy thinks, oh, a minute, what a treat. The second thing is my website is very, very, very highly optimized. I'm not showing off, it is. Like if you visit my site from Belfast or Dublin or somewhere like a data center like in Europe, it's going to load within about 1.3 seconds, fully rendered within 1.3 seconds. The exact same website on the exact same CDN, the exact same structure, the same images, the exact same files, takes a minute for someone in Nepal, just because they live in Nepal. I haven't built the site any different. I haven't built the site worse for Nepalese developers or people. That's the tax these people pay just purely because of where they live. And these are people who are coming online next. Though you may have noticed already, each of these stories occurred in Southeast Asia, in the Far East. The Far East is a very interesting place right now because, has anybody heard of the next billion users? Anybody heard of this? Okay, only like one person, cool. The next billion users is an initiative spearheaded by Google. The next billion users aims to service the next billion people who are about to come online. It's actually more than a billion as well, actually. We estimate, or it has been estimated, that in the next 5 to 10 years, we're about to introduce another 1 billion people to the internet. The internet is such a big part of our lives that we assume everybody has it. There are a billion out there who are going to be coming online in the next 5 to 10 years. If you're interested in this initiative, just literally Google next billion users. You're probably going to find this resource by Quartz. It's a very good canonical resource with lots of information. But the interesting thing about these 1 billion people is most of them live here. Who's seen this graphic before? Oh, okay, a couple. Right, so fun fact. More people live inside of this highlighted area than outside of it. Even taking into account how much ocean there is under that white splodge, more people live inside this area than outside of it. And this is the majority of our next billion users. These are people who, so far, the West has kind of forgotten about. When we look at the countries inside this splodge, we get some really interesting data. Bangladesh, for example. In fact, I'm going to swap back to this. One thing you'll realize is when you look at this, it covers places like India and China, right? So we've got very densely populated parts of the world. This is why there are so many people there, right? Very densely populated regions. Bangladesh, average connection, 3.5 meg, thereabouts. Only 15% of Bangladeshis are online at all. With 3.9 million broadband subscriptions, that represents just 2.4% of the population with a broadband sort of Wi-Fi solid stable network. With 134 million cellular subscriptions, 83% of the population get online via mobile. That's 34 times more people with a mobile-only connection than broadband. India, right? 3.5 meg connection, a quarter of Indians are online. With 17.1 million broadband subscriptions, that represents just 1.3% of the population with a dedicated broadband connection. With 1 billion, and that's not a typo, that's billion with a B, cellular subscriptions, that represents 79% of the population getting online with a mobile device. That's 58 times more people. Don't worry, I'm not going to do every country in the world. There's only a couple more. Pakistan, right, 2.5 megs, right? This is the slowest connection of the group. A fifth of people are online. 1% of the population, just 1% have access to broadband. 67% have access to mobile. That's a delta of 70 times more people on a mobile connection rather than dedicated broadband. And finally, Indonesia, the highest connection speed of the group, 4.5 meg. A fifth of Indonesians are online. And with 338 million cellular subscriptions, we find this interesting statistic where 132% of people have a mobile connection. Now, this is probably because the Far East is the world's fastest growing economy, and Indonesia is its fastest growing country, and Indonesia is a very kind of online country. What I'm getting here is that probably Indonesians have, on average, more than one mobile subscription, right? For example, I've got 2 SIM cards. I've got like my British SIM card, and I've got my travel SIM card. Similar kind of phenomenon in Indonesia. But this represents a staggering 121 times more people get online with a slow, high latency, low bandwidth connection than they do with broadband. Averaging this data out across this region, just 3.5 meg average speeds. 20% of people are online, 1.5% have broadband, and 90% have cellular. Comparing that with us, we find that we've got Nearly 13 meg speeds, right? Much faster, much, much faster. 2/3 are online, a fifth with broadband, and this is crazy. This is the highest number I've ever seen for Poland. 150%, right? Who's got 2 SIM cards? Who owns 2 SIM cards? There we go. That's you, the bottom one. What does this tell us? This tells us that we're dealing with a completely different profile of user. When we talk about building mobile first in the West, we normally mean, oh, I open Sketch and I make a small viewport first, and then I only write min-width media queries. And we think that satisfies this thing of we do mobile first. If we truly globally want to be building mobile first, we need to be testing on mobile devices first. We need to treat a 13 meg connection as progressive enhancement, right? We can't assume that's the norm, because for over 1 billion people, it really is not the norm. We're building for a completely different profile of user. It changes everything. If we want to build for a truly international audience, we need to build by default throttling our connections, right? And then once a week, we turn throttling off and be like, okay, this is how good it will feel in Poland, but for the rest of the time, it feels normal everywhere else. So when I go through this kind of thing with clients, I always get the same first question, well, how fast should we be? How fast is fast enough? And the problem is I don't actually have an answer to this. Nobody has an answer to this. It's impossible to say how fast a website should be. There are guidelines. If you follow things that Google say, you want to be hitting a speed index of 1200. That's very ambitious, and it can't work everywhere. You can't have the same speed in Wrocław as you can in Nepal, right? It's impossible. So normally what I tell people, especially commercial clients, is just be faster than your nearest competitor. If you are about to embark on a performance optimization task, your benchmark should be, let's just be faster than our nearest competitor. Identify who your closest competitor is, see how fast they are, and just start by beating them. That gives you a commercial competitive advantage immediately. I found a great site recently. Found it about, I don't know, 9 months ago maybe. It's called DareBoost, and DareBoost has this competitor benchmarking tool. You can just drop in 2 URLs, and it'll run off and it'll go and get a comparison of each site side by side. So if you're about to embark on a performance optimization task, start here. Show this to your manager. Say, hey, look, the bad news is that our competitor is half a second faster. Give me 2 weeks, and I'll make us 3 seconds faster than them. This is a really great place to start. If you've got a little more cash, this is a free tool. If you've got a little more money, there's a tool called SpeedCurve. Anyone used SpeedCurve before? Okay, not many. SpeedCurve's amazing, but it is kind of expensive. You can do competitive historical benchmarking here, where unfortunately the slides are like attached to the ground, so anyone further back than 2 rows can't see it. We can see here that we've got historical data showing that the Huffington Post is markedly slower than the New York Times and the Guardian are roughly the same speed. This kind of historical benchmarking is a really good way of getting non-technical stakeholders interested in performance. Because your manager might not know what DNS propagation is, they might not know what a TCP connection is, but they can see that we need to be faster than our competitors, right? So let's talk about getting there. How do we start building these faster websites? I've got a handful of tips, and they're not like BuzzFeed, 3 crazy things to make a fast website. They're a bit deeper than that. They're a bit more fundamental and philosophical. And I want to go through some of these with you. The 0th step in building fast websites is just want a fast website. The easiest way to build a fast website is intend to do so. You can't build a fast website by accident. It's not going to happen very easily without any effort. Now, people normally laugh when I tell them this, because it sounds a bit pretentious, right? It sounds a bit kind of like a tongue-in-cheek comment, and it kind of is. But genuinely, any organization that starts with this step is going to end up with a fast website. Make sure it's a business goal. Make sure your designers, your marketing team, your software engineers all understand the importance of we want this website to be fast. As soon as we intend to make a fast website, it's going to happen much, much easier. So yeah, do not underestimate the importance of this step. It's going to be very important to kind of the overall success of the project. Start here. Start by wanting a fast website, and everything will become so much easier. Excuse me. Okay, let's get to the proper ones, right? The first step, understand the problem, but truly, truly understand the problem. Stress testing your site from different points of view is going to be a great way to start achieving this. You need to properly understand it. You might think that, well, the site feels kind of fast, but where's the data, right? Where's the actual proof that it is or it isn't? If you're fast from a nice office in the center of Wrocław, you've got a nice, dedicated line, that's going to be fast, but that's not fast everywhere. That doesn't mean you're going to be fast everywhere. If you can be fast in the middle of a field, in the middle of nowhere, or on a 2G connection, the good news is that everything after that comes for free. Normally when I discuss performance optimization sort of techniques and projects with clients, I usually tell them the same thing. If you can make your site fast on a 3G connection, imagine how fast it will be if someone's lucky enough to have a wired connection or a fiber connection. The site probably arrives before you've even asked for it, right? That's how fast it's going to be. Facebook did something a couple of years ago called 2G Tuesdays. Now, imagine a company like Facebook, all their software engineers are sat over in Silicon Valley. They're all very spoiled, they're all very, they've got nice, brand new, shiny MacBooks, expensive machines, they've got dedicated lines into the office. They've got no idea how fast their website is. It feels fast all the time for them. So a few years ago, they had the idea, well, how about we throttle our traffic internally? How about every Facebook employee, every Tuesday, gets served a 2G version of the site? And they did, and they soon realized that, oh shit, we haven't done a very good job of this. It gave them a real understanding that people in the real world, people who don't have $3,000 laptops on gigabit Ethernet lines, they do not access the site like Facebook engineers do. Another thing that's good to remember is that people very rarely visit a website on the kind of machine that was used to build it. You think about what machine your friends have at home, or what phones your family have. Very few people visit websites on development-ready machines. They visit websites on the machine that's been in their house for the last 10 years, right? People don't upgrade as often as we do. We live in this bubble where we think, oh, well, people have got fast connections now, right? Not true. Now, me personally, I lack the skill to set something like this up. I wouldn't know how to go about ring-fencing IPs and throttling things on the network for just a certain subset of people. I could get someone to do that for me, but I can't do it. So what I do is I use a tool called Charles, right? Anybody used Charles Proxy before? Yeah, a handful of us. So it's free. Write this one down. Go and download it. Charles Proxy allows you to throttle specific endpoints. So you're probably used to your Chrome dev tools. You can slow down your connection speed. With Charles Proxy, we can literally put in specific endpoints. This means you can slow down your local host, or you could slow down your dev site or your staging site, but leave the rest of the internet nice and fast. I normally enable this for a few days a week with a client and just say, look, for today, we are only going to visit your site over a 3G connection. And the frustration the client feels soon makes them realize that, okay, we do need to improve things. We do need to make things faster. So Charles Proxy is a really effective, affordable way of starting to build up this idea. But the bad news is it's not just connection speeds anymore. In fact, just solving the connectivity issue, solving the network issue, is only a small fraction of the battle. Who's got a phone like this in their pocket? This is an iPhone 7. I got an iPhone. Anyone got like a late iPhone? Anyone got an iPhone 10? Show off. Okay, who's got like a new Android device, a fairly modern Android device, right? Yeah? Yeah, way more hands, right? That's good. Look at you. Look at you. And that's kind of what you'd expect from a northern well, any kind of European country, I guess. Current advice coming out of Google's performance engineering team, suggests that this is a more representative device. This is a Motorola Moto G4. It's not the oldest phone in the world, but for a good idea of global capabilities, this is the kind of device we should optimize for. If you operate in a truly global sort of way, truly global landscape, this device right here is the one to use. I think you can pick them up for about 150 euro, maybe even less. Add this to your device lab. If you've got a device lab for testing responsive sites, we need to have a device which will also test for capability, CPU, actual device capabilities. Just doing a quick side-by-side comparison, this is a site called geekaphone.com. Quick side-by-side comparison shows that already, immediately, with nothing else, the Motorola G4 is about half as fast as an iPhone 7. Imagine just immediately everything you do feeling half as slow because you've just got a different phone, because you couldn't afford a shiny iPhone 7. More forensic tests from phonearena.com show that across nearly every single benchmark, the iPhone 7 is 3 to 4 times more capable than the Moto G4. That means that every time you visit a website on a nice new phone with a good processor, that's going to feel 4 times faster than it will for the global average person. 4 times is a huge, huge number. You've hopefully noticed in DevTools we have this kind of this throttling for your CPU and your bandwidth. Now, the bandwidth throttling, this is a good start. I'm doing a workshop in a couple of hours in which we will look at a more suitable alternative to this. The network throttling is a good start. The CPU throttling is the important bit. Turn on CPU throttling, slow it down by sort of 4 or 5 times, and see what your site will really operate like on a commodity Android device. There's no replacement for real devices, though. Like I say, go and buy a Moto G4. Whoever controls the credit card at your company, get them to add a Moto G4 to the device lab. This is where I sound like a huge hypocrite. I don't have a Moto G4. I've actually got a Nexus 5, which is older than the Motorola G4. I was working with a company recently. I do all my performance testing on this phone. I was working with a company recently, and they just rebuilt their website. And they'd rebuilt their M.dot website. So it's literally only for mobile devices. And they finished building it, and they sent me an email. Hey, Harry, we've built a new website. We think it's, we think it's pretty good, but can you tell us if it's fast enough? Pro tip, hire a consultant before you need one. Because what ended up happening is I went in and I looked at their site. They'd spent 6 months and hundreds of thousands of pounds rebuilding it, and it was bad news. I was like, yeah, it's not fast enough. You need to rebuild it. You've done a really bad job. What they'd done is they'd built it as a fully client-rendered JavaScript application with tens and tens and tens of thousands of lines of JavaScript sitting right on the critical path. What ended up happening was just to parse the app.js, just to evaluate that script, took nearly 2 seconds. This is completely divorced from caching, from network speeds, from all of this kind of stuff. This is runtime, so it doesn't matter if you are on a nice fiber connection, you still get this cost on a bad or sort of old CPU. I mentioned the train line, a different client of mine. 0.3 seconds was worth 8 mil to them. This client was throwing away 1.7 seconds, well, really throwing it away, just got rid of it, just by churning over that many lines of code. So build up an idea of realistic conditions. We do operate consistently in something of a bubble. We have generally quite good machines, generally quite good phones, but it's not globally representative. Build up an idea of network conditions, of device capabilities, processing power, things like that, to truly understand where the lowest rung lies. I can't stress this enough. If you optimize for the lowest possible scenario, everything on top of that is completely free. Step 2, know what's going on. This is, again, really important. It sounds quite simple, but this is really difficult to do. This might be the hardest thing to do, actually. Know what's going on. This is a lot of my time as a developer. I spend a lot of time doing this. Anyone else agree with this? Like, what on earth is this script? Where does this analytics code come from? I didn't install this. What the hell do we even use this thing? Right? We get this all the time. Especially if you work in distributed companies, or companies with different siloed departments. One really common thing is that as a front-end developer, you'll build a website, and you'll push your chair back from the desk at sort of 5 p.m., and you'll think, today was a good day, I built a really good website today. And you go home, and you visit the website again. For some reason, you look at it on live, and all of a sudden, holy shit, like, where's all this stuff coming from? There's tracking scripts. This ad network, I didn't know we used this ad network. This is really slow. Where are these unoptimized images coming from? That's because as a developer, you're building tools to just give somebody else control. We relinquish a lot of that control by giving away CMSs, tag managers, things like that. We end up losing a lot of the power we had. So know what's going on. Other people can add things to your site. There's kind of like a Schrödinger-y/Heisenberg-y effect by you add like an analytics tool or you add an A/B testing tool to optimize the site, but that has the overhead of it will make the site slightly slower. Measuring something will affect the results you get out at the end of it. So a lot of the work I do when I work with new clients and new companies, I'll schedule meetings, right? I will say, look, okay, we can make the website faster, but first, I want a half-an-hour meeting with your marketing department. I want to find out what analytics your marketing team uses. I want to know why they use that specific product. Is it just cheaper or free? Is there a better one we could spend a bit of money on? I want to know what kind of A/B testing tools they use. Because until you understand what's under the hood, you can't make anything faster anyway. So this takes time. This is quite a long, drawn-out process, but this is imperative. I mentioned tag managers before. Honest show of hands, who's not sure what a tag manager is? Because I can quickly explain what a tag manager is. Cool, right. So picture the scenario. You're a front-end developer or a developer of any kind, and you build a website, and someone comes to you and says, hey, look, can you quickly install this analytics package? And you say, well, yeah, I'm a bit busy, but sure, yeah, I can do that. And you do it, and you put it live. Then the next day they say, hey, thanks for that. We've got another one. Can you install this one as well? And you're like, can you just put it on the to-do list because I'm actually quite busy and I've got to, and so the marketing team think, oh, this developer won't help me out and I just want to get this thing installed, and the developer's thinking, well, I've got work, like proper work to do. So somebody invented a tag manager, and a tag manager, you just install one line of JavaScript, and this line of JavaScript is a conduit to an admin interface somewhere, where a non-technical user doesn't have to ask you to install new bits of JavaScript, they can just add it themselves. It's production JavaScript. It's not production quality JavaScript, oh no, definitely not, but it does end up on production. So that means that through a CMS somewhere, through an admin panel, someone can say, I want to track clicks on this button, or I want to track things here. And it's basically a way of someone writing JavaScript that goes live whilst completely cutting out the dev process. Sounds like a great idea, right? So this is a client I worked with very briefly. This is a waterfall chart showing just loading one of their pages. The green is what the user turned up for. The green is the website. This is what I wanted to see. As a person visiting this website, I wanted to see, I can't remember what it was like opening times or whatever. The red is what we ended up giving them. This is analytics, this is tracking codes, this is beacons and pixels, this is ad providers. This is disrespect, is what this is. Because if you're a user on a data roaming plan, where each megabyte costs you actual money, you wanted to see this, yet you've just gone and paid for all of this. It's very simple. This is disrespect. I mean, there's way more behind it than that. No one does this on purpose, but this is the kind of thing that happens. The developer thought they built this, but the user ended up getting this, and this huge disconnect is part of the reason why performance ends up getting so bad, because nearly all of this red was actually added by a non-technical person, right? We don't always see, don't always know that this stuff's even happening. It's imperative to know your liabilities. For years we've called them assets, right? Can I get the assets for the homepage? They're not assets, they're liabilities. Everything we add to a web page is another potential thing to go wrong. A client I was working with, very, 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 very good client, have to say that, they're in the room. We were working on their site, and there was an optimization tool, meant to be an optimization tool, designed to basically improve conversions, that kind of stuff. Unfortunately, again, the slides are like plugged to the ground. We found out this optimization tool was adding 98% of the runtime overhead. The tool designed to optimize the site, so increase conversions or increase revenue, etc., was contributing 98% of the runtime overhead. If you want to find this kind of stuff out, again, in the workshop I'm doing in a couple of hours, we'll look at this in a lot of detail. If you generally just want to find who is causing you runtime overhead problems, in DevTools, just go to Performance, Bottom Up, Group by Domain, and it will literally give you a list of every domain and how much runtime overhead it contributes. So you can quickly see that, oh cool, not my fault, right? It was someone else. The bad thing about it being someone else is that it's much harder to fix, but the good news is you can tell your manager, hey look, not my fault, not my problem. Actually, no, it is your problem, it's just not your fault. That's the worst way it could be. So, I got an email from the CTO. So the CTO and I worked together on performance efforts, and it was a huge success. The entire platform was restructured around being fast. The team did an absolutely astounding job. And part of that job was ripping out all the crap, just saying, look, we don't want any of these third-party things. Let's start by removing all of this. And it was an outrageous success. First paint was at 0.8 seconds, right? Which I think is probably a class leader for the e-commerce space, right? 0.8 seconds start render, first paint, absolutely incredible. And the site was thriving, right? They'd done an amazing job, and the marketing team were like, this is so good, this is great. In order to make it better, can we put some of the tracking code stuff back in? Can we put more of the A/B tests? I was like, no, the whole reason it's good is that we got rid of all that. It's like, no, come on, put it back in. And they put it back in, kind of a battle we didn't quite win, and we added 1.3 seconds onto our start render. The site went from being start render at 0.8 seconds to 2.1. The painful irony is that the tools that caused this are sold and marketed as optimization tools. One of the single biggest aspects of improving conversions is having a fast website. And as soon as your optimization tool adds 1.3 seconds of overhead, you're already on the back foot. And as a developer, it's very, very hard to get around this. So it's really important to understand exactly what is affecting your site once it goes live. In terms of identifying third parties, what we'll look at now is Chrome is getting much, much better. Chrome is the most powerful tool I've got available to me in terms of performance optimization. If you're running a version of Chrome with experiments enabled, network request groups support is a setting you can turn on, and what that will start to do is it'll start grouping things by where their origins are. That's just a simple experiment we can turn on. Now, I was looking at the BBC's website. Oh, sorry, another thing as well is you can turn on this product column. The product column is a really great column in the network inspector, and this will tell you roughly, or if Google is aware of the third party, it will tell you that, okay, this file came from this third party, therefore you can easily work out what's going on. So, on the BBC's website, there's a file here which had a, sorry, I'm getting ahead of myself. Turn on the product column, you start to see information about which third-party providers are sending files over the wire. I identified a problem, right? A file here was taking 35 seconds just to do its initial TCP connection. One TCP connection, 35 seconds. And, hopefully you can see right here, this is tethered to the load event, right? So this was a blocking script. The load event didn't fire until nearly 40 seconds because of one third-party script which had a 35-second TCP connection time. Using the product column, I could see that, okay, it's something called Rubicon Project. And then a bit of Googling told me that Rubicon Project is, of course, an ad provider. In a situation like this, you need to raise support tickets with that ad provider. Maybe choose a different ad provider altogether, right? Or, as a last-ditch attempt, just tweet at the ad provider saying, hey, any known problems, because you're screwing up my performance. So this kind of tooling is absolutely fundamental in working out and assessing who is making you vulnerable, because it does make you vulnerable. Another client of mine, they use something called Adobe Tag Manager, and the problem isn't specific to Adobe Tag Manager. If you use Google Fonts and you don't asynchronously load it, if you just put link rel equals style sheet in the HTML, you are also vulnerable to this scenario I'm about to describe. Adobe Tag Manager, as well as being a tag manager which is already evil, it's a synchronous script, it's a blocking script, which means that if Adobe Tag Manager has an outage, we go offline for 1.3 minutes. Because it's a blocking script, Chrome has a built-in timeout. So if Adobe Tag Manager has an outage or goes offline, we will show users a blank screen, a completely blank screen, for 1.3 minutes. 1.3 minutes, that user's going to go elsewhere. Oh, the site's down, I'll go and buy it from somewhere else. So these kind of third parties, and again, we'll look at this in the workshop later, can be complete single points of failure. We could lose tens of thousands in revenue if we have an outage from a tool that is meant to make performance or meant to make conversions more optimized. Web page test make publicly available a black hole server. So if you're using Adobe Tag Manager or you're using Google Fonts and you're thinking right now, oh shit, like this could be us, this is how we work it out. These slides are already online, but if you want to take a quick picture of this, I would recommend it. This IP address is a publicly available black hole server, and if you route any third-party domains through this IP address, it will simulate a full outage. So what I normally do with clients is I add loads of typical third parties, like Google Fonts, Adobe Tag Manager, New Relic, whatever third parties I'm interested in, I add them to my host file, reload the page, and we see what happens. And more often than not, there is something in there that will take us offline for 1.3 minutes. So my advice here is don't prioritize your own metrics over your user's experience. There's no point measuring things if that measurement is going to affect performance so much that users leave. Right? You're measuring nothing. Excuse me. Okay, talking about measuring then. Step 3, the final step. Measure everything. Measure absolutely everything. Even data you don't think you need yet, capture it anyway, because you'll find some insights. Measuring everything, we do it for 2 main reasons. One, how do we know what's wrong? You can't fix what you can't measure. So you need to start with something. You need to start with, okay, I think this is the problem, and I only know that because I've been able to measure it. Then we instrument fixes, we implement changes, and then afterwards, the second thing we know is, okay, it's right, it's now correct. A lot of people fail on the first one. They don't measure the before. So they go in blind, they think, oh, I'm going to make the site faster. And yeah, they might make the site faster, but which bits? Which bits are problematic? Who's got Google Analytics on their website? Right, who hasn't logged into Analytics for about 6 months? Yeah, only one honest person in the room. Analytics is constantly capturing very rudimentary performance information, RUM, real user monitoring. So normally when I start a performance optimization project with a client, I will say to them, look, I want access to your Google Analytics, or whatever analytics package they're using. I had a client get in touch with me, and they run like a holiday travel company in Iceland. And they said, look, people come to Iceland, they want to do like whale watching, they want to go and see the Northern Lights. They would book a trip through our website. Can you make the homepage faster? And I was like, well, I can make the homepage faster, but people probably aren't landing on your homepage. They're probably Googling Northern Light Tour, and they're landing on the actual product page. So give me your analytics, and we'll see what the problem is. Turns out their homepage was by far the fastest page on the website. The slowest pages were specific tours, right? Specific products. So we use that information to start optimizing in the correct areas. And if you've got Google Analytics, you need to go to behavior, site speed, page timings. Again, in the workshop later, we'll be looking at this in more detail. And we can start to get really good overviews of geographic locales. The map overlay, this is how I found out that Nepal was slow for me. In the map overlay, we can literally see which countries respond in which times. We can then cross-reference things. This GIF is enormous, and it's about to beach ball my Mac, so I'm going to take a drink. Oh, wow, it didn't. It normally beach balls my Mac. I'm going to take a drink anyway. We can grab this geographical information and then map it against a secondary dimension, such as which page. You can really easily see that, oh, okay, our biggest customer base is Germany, and our homepage is the slowest in Germany. Therefore, we need to fix that immediately. Gathering this kind of information tells you where to start. Going into a performance optimization project blind means that you could spend 2 weeks optimizing the wrong thing. So whenever I start a new project, I dive into this, and I will look at pages. If I know that one page is really fast in Poland, but another one's really slow in Poland, I will look at the difference. Like, do we have a certain third party on the other page that might be the problem? So getting data before the fact is massively important. We've talked mainly about Asia and the Far East. Interesting thing here is Brazil. Brazil is also considered an emerging economy. I decided to do some research into what the internet is like in Brazil. Has anyone been to Brazil before? Yeah, I've never been, unfortunately, so I had to do everything kind of like second-hand research. But I found this infographic. In Brazil, if you want to buy 500 meg of data, you have to work for 8.6 hours at minimum wage. If you work a minimum wage job, 8.6 hours is like a full day's work. Imagine working for 1 day a month, thinking, oh, it's the 15th of the month, therefore I'm working for my data. Super expensive. If these people turn up to our website and 99% of the files are tracking scripts, we're spending money that they've literally earned, right? They had to work for that. I mentioned earlier, I've got a second SIM card. I've got like a travel SIM card. I use my travel SIM card maybe 15% of the time, so it's not, it doesn't get very high usage. But even in just, I think a year, I used 14 gig of data. I decided to work out how much it would cost for 14 gig of data in Brazil, and it's about 28 days. Can you imagine working an entire month of your year just to earn 14 gig of data? That's how expensive data is in these parts of the world. We can't just go wasting it. So speed curve, we mentioned this really briefly. So I got my before data. I looked at analytics or whatever analytics package I had available. I gathered the before. I then used that information to implement a fix, or what I thought would be a fix. I used speed curve to set up some monitoring from in Brazil. So I was like, well, I need to measure the after now. I need to make sure that whatever I implement is going to be effective. And sure enough, implemented a fix, and it turned out to be the correct thing to do. If I hadn't had Google Analytics before and speed curve after, I would have not known if my work was effective. I may have never even done the work in the first place. This is why it's so important to measure both before and after. And then we can do things like setting up budgeting. So I thought, well, if I know Brazil's a problem area, I think I've implemented a fix. I need some alerts if anything ever regresses. I need to make sure that I'm aware of any regressions, because what normally happens with a performance project is you do the work and the site's nice and fast, and everyone cares for like a month. Then after a month, they start putting stuff back in there. They stop optimizing images, and things just get back to where they were again. So it's important to set up monitoring and budgets. People in management don't like the word budget, so it's just monitoring with alerts. So I used my site as an example. It's a pretty simple website, not much going on, but you'll notice there are quite a lot of images on there. Not the most complex site, but we've got third-party providers, we've got an ad network, we've got some third parties in here. This website from, this is Ireland, this is Dublin. be fully rendered in 1.3 seconds. Oh, sorry, starts rendering in 1.3 seconds. Again, this isn't me showing off, this is just trying to say that in Northern Europe, you get incredibly good connection speeds, incredibly good. I'm under budget every single day. To be fully rendered, it is also 1.3 seconds, vastly under budget every single day. If we do move over to Brazil, even after implementing those fixes, about 50% of the time I go over budget. And you also notice that this line is very erratic. It's not very consistent. There is no kind of consistency day on day. It's all over the place. About sort of 10-15% of the time, well, actually 10% of the time, I'm going over budget on my fully rendered. Now, the thing is, these are fairly stable connections. Even though it's in Brazil, this instrumentation is a fairly stable connection. So I decided to really turn things up a bit, and I created what I call a very bad network, right? In SpeedCurve, you can create custom profiles, and I created a really, really bad network. Very slow down speeds, very slow up speeds, very high round trip, and the most important thing is I instrumented 10% packet loss. So anyone who knows much about TCP will know that packet loss, especially on mobile, is very, very highly correlated with slow load speeds. Packet loss is an absolute killer, and it's most prevalent on slow connections, mobile connections. With these kind of device settings, my graph looked like this. Every single day, I'm going well over budget. It's a very erratic graph. There isn't any consistency, but I'm completely overshooting my budget. This is a realistic sort of 2G mobile connection prevalent in emerging economies. So even setting up instrumentation in Brazil, which is theoretically not great, doesn't give me the full idea of what's going on. If you compare the top line, that's the very bad network, with Brazil, Ireland, etc., you can quickly see just how different things are. There's no consistency here. We have to be very defensive. This kind of tooling has completely revolutionized how I approach performance optimization because the results are absolutely startling, absolutely, game-changing. Excuse me, sorry. So, I just want to close. I've gone a couple of minutes over. I'm going to try and summarize 100 slides in 3 bullet points. The first thing you need to do is care. Just actually prioritize performance. Actually think about what performance means to you as a company, whether that's revenue-based or engagement-based, but also care about what it means for your users, your customers, right? What do they need? Do you have customers who are completely geographically scattered? Do you have customers who might be on very expensive tethering connections? Truly understand those customers, understand what their device makeup is, look at your analytics, delve into everything, try and build a very, very good overview of who you are building for, and also the networks that the conditions they exist in. And finally, measure absolutely everything, the before and after. All the data you can get hold of, just grab it, look at it, interrogate it, because it will give you a really good idea of where to start, and also will confirm whether you've done a good job. All the statistics and data in this talk can be verified and fact-checked. So if you're interested in data, it's all there. The slides are already online, so if you go to speakerdeck.com/csswizardry, you can get access to the slides immediately. The last thing for me to say is just thank you very much for your time.